Okay, today we're going to continue on with the area. Lesson 8.6 is going to talk about the area of trapezoids. So we first need to know, what is a trapezoid? What does it look like? Again, we have learned about our polygons in a previous unit, but it's good to be reminded. A trapezoid has one pair of parallel sides. So a trapezoid could look like this, in which you have two sides that are parallel to one another. The other two sides are not parallel. So the definition of a trapezoid is one pair of parallel sides. The quadrilateral with one pair of parallel sides. Now, to calculate the area of a trapezoid, you can see that it's made up of several different shapes. If we want to break this into different shapes, we could draw a triangle here, a triangle here, and then we would have this rectangle on the inside. This would be three shapes that we would need to calculate the area of to get the total area of this trapezoid. But instead of doing that, instead of finding missing sides and calculating those three separate formulas, we have the area of the trapezoid as a shortened version that will save us some time. So the area is always 1/2 the height of the trapezoid. So remember, you're looking for that 90 degrees when you're looking for the height. And then you're going to take the sum of the bases and multiply it by that. So the sum of the bases means to add, and so we'll add the bases. So remember, this is a base and this is a base. The parallel sides of a trapezoid are called the bases. So there's two of them. Alright, so I will typically write the formula as 1/2 the height times the quantity base 1 plus base 2. This will be how I write it. You can also write it like height times base 1 plus base 2 divided by 2. Either way will give you the area. They're the same formula. Okay, so on the example 1 it says find the area of a trapezoid. And so we have this trapezoid. I want to label my base. Here's my base 1. I have another base 2. They're the parallel sides. And then I have that height. Remember, you can identify the height by finding that perpendicular distance to the base. And so now we'll just substitute those values into our formula and calculate. So once we do that, we're substituting in our values and we'll simplify. And so we get a total area of 126 square meters in this example 1. So the exercises for example 1, 1, 2, and 3, I want you to try to do that using the area formula 1/2 the height times the quantity base 1 plus base 2. Again, you want to label your trapezoids. Remember the bases. It doesn't always have to be the one that's on the bottom, like on number 2. It can be the ones that are on the sides, like this. As long as they are parallel, these sides are called the bases. So you're looking for those parallel sides. These are parallel. They won't ever intersect. So this is base 1 and this is base 2. And then on number 3, these are parallel. So this is base 1 and this is base 2. And then your height is identified by that right angle. So I'll give you a couple minutes to work through this. Okay, so for number 1, when we're substituting our numbers into the formula, 1/2, the height is 7 times base 1 plus base 2. So remember, we do our parentheses first. If there's something that we can simplify here, we will. So I'm going to go ahead. There's nothing we can do inside the one with 7. But 10 plus 6 is 16, so I'll simplify that. And you can just type this into your calculator to get the area for number 1. This time we will get 56 square inches when we get this area. Number 2, the area is 1/2 the height times the quantity, base 1, plus base 2. Simplify what's in your parentheses. So we get 27. And then we want to just type the rest in our calculator to get the area. So that would be 135, and your units would be square centimeters here. And lastly, on number 3, plug it in. So we have the area would be 1/2 the height, which is 8, times the sum of the bases, 11 plus 17. And so we can simplify that second set of parentheses and make that a 28. And now we can do our multiplication in our calculator. Okay. Alright, example 2. This time, just like we've done in previous lessons, we're going to calculate a missing length. So this time we're missing this base 1. We have the height, we have the base 2, and they give us that the area is 170 square inches. So we're going to work backwards on this one like we've done in the past. That means not background, backwards. Work backwards. And so we're going to substitute what we know. We know the area is 170. We know the height is 10. We know one of the bases is 16, and we don't know the other one. So how do we get rid of a fraction of 1/2? We would multiply both sides by 2. Or we could say, what is 1/2 of 10? And say, well, that's 5. And so then we would have 5 times the quantity, base 1 plus 16. And so we can now divide by 5 on each side. And we would end up with 34 on this left side and base 1 plus 16. And from there we would subtract 16 to get 18 as the base that we're missing, 18 inches. There are different ways you can go about simplifying this formula when you're solving for a missing side. Alright, so exercises for example 2, we want to find the missing measure, so we're going to be working backwards here. And so for number 4, we know the area of the trapezoid is 1/2 the height times the quantity, base 1 plus base 2. The height we do not know this time. Base 1 could be 5, base 2 could be 7. And the area they give us is 18. Okay? So from here, on number 4, we're trying to find that height value. I can go ahead and simplify what's in my parentheses since I have both of my bases. 5 plus 7 is 12. And I can say, well, 1/2 of 12 is 6. So I get 6 times h. And then I can divide by 6 on each side. So 18 divided by 6 is 3. And we're talking about meters. Number 5. If I write it like this, with the height times the quantity, base 1 plus base 2 divided by 2, that's another way that you might write it if you get confused with this way. So we could do it this way with the 56 in the A. The height is 7. Base 1 is 6. Actually, base 1 is the missing one. But the other base is 6. So we're trying to find the base 1 here. And we'll divide that by 2. Now, to get rid of the fraction, we'll multiply by 2 on both sides. So we get 112 equals 7 times the quantity, 6 plus base 1. My 2's ended up canceling here. From there, we can now get rid of this 7, because the 7 is multiplying to this quantity. To get it on the other side, we divide 112, divide it by 7, and we would get that to be 16. My 7's canceled. Now I'm left with 6 plus base 1, and the last step would be to subtract 6 from each side. And so for number 5, our answer for base 1 is that it's equal to 10 feet. Number 6. So the area is 342, 1 half. The height is 12 this time. Base 1 is 31, plus the other base, or actually saying base 1 is the top one, so we'll stick with that. And so now what can we do? We can say, well, 1 half of 12 is 6. And we have this 31 plus base 1. 6 is multiplying to the quantity here, so we'll divide both sides by 6. 342 divided by 6 will give me 57 equals 31 plus base 1. And lastly, to get base 1 by itself, we subtract 31 on each side. So 57 minus 31, that gives me 26 equals my base 1. And we are talking about yards. Alright, so for example 3, find the height using the Pythagorean theorem, then find the area of the trapezoid. So in this case, you can see we have a right triangle, and we have two sides of that triangle. We want to find the height, so we could use the Pythagorean theorem to find that missing side. And so we're going to just plug in our numbers. We have that a squared plus b squared equals c squared for the Pythagorean theorem. C is the important one, the longest side. It's the one across from the right angle, so that's 15. That gets substituted in for by c. And the other two numbers, the height and the 12 side, is substituted for a and b. And then we'll simplify. The height ends up being 9 when we calculate that Pythagorean theorem. From there, we can get the area of the trapezoid just by substituting into the formula there. Okay, so let's see, there we go. So the formula for the trapezoid, we have 1 half height base 1 plus base 2. The height is 9. One of the bases is 22. The other base is 38. And we get the area of the trapezoid to be 270 square units when we simplify. Alright, the last two, try on your own. Try to get that missing height using the Pythagorean theorem. Then use the area of a trapezoid. Okay, so you can see on number 7, I've started doing the Pythagorean theorem here. The most important letter to make sure you get right is that C spot, the longest side, 15 across from the right angle. And so 15 squared equals the side 9 squared plus the missing height squared. We're trying to find that height so we can calculate the area of this trapezoid. And so I just simplified here our usual Pythagorean theorem. The height ends up being 12. And then we now want to calculate the area of this trapezoid by doing 1/2 the height, which is 12. The length of the bases, one of them is 20. The other one is not just 22, but it's 22 plus 9, which will give me 31. And so now I'll just simplify 1/2 times 12. 20 plus 31 will give me 51, and you can type that entire quantity into your calculator, and you should get the area to be 306 square units. Number 8, calculate the height. The C is 30 in this case, so C squared equals A squared plus B squared. C is 30. A could be my 18. And the missing height, we get 900. 18 squared is 324. That's the height squared. And so we'll subtract 324 from 900, and we get 576 equals that height squared. So again, to find just the height, we'll square root each side, and we get the height to be 24 units. From there, plug it into your formula for the area of a trapezoid. 1/2 the height we found to be 24. Add the bases together, so my base here would be 25 plus 18, which would be 43. So I need the total length of the base, not just part of the base. So 43 plus the other base of 34. So again, you might want to label these base 1 and base 2, and we found the height to be 24. We only need those three numbers, so if you use 30 in the area calculation, you will be incorrect. 1/2 of 24 is 12. 43 plus 34, that will give me 77. And so I get 12 times 77, which is 924 square units, since we're not given a unit value here. We'll just use units. And that is all for the trapezoid.